So many times when you do calculations with measurements, you receive a final answer that has a unit that is different than the unit that you started with. We just got done talking about how to do conversions of measurements from one unit to another. Many times those final units are called derived units because they result in combinations of units. One example is volume. If we were to do length times width times height of a cube, and that side of the cube was in centimeters, when multiplying all of those, we would get something in centimeters cubed. That's different than the unit that we started with, and it's a combination of the units that we were given based upon the mathematical operation. A really popular, or I should say, a common unit that chemists make use of is density units. And you're going to have a lab that revolves around density in experiment number 2, which is titled measurements. But the property of density, which is a ratio of a substance's mass and volume, the units that are associated with density are derived units because they come from the mathematical operation used to determine density, which is taking the mass of something and dividing it by the volume. So, for example, for water, if I have 50 grams of water and the volume of it is 50 mils, when doing that division, the units that I get are grams per mil. We would say that that unit is a derived unit based upon the equation for density. So density, as I said, is an important property when you're going to investigate more in lab. It's the ratio of a substance's mass and volume. And what's neat, one of the neat things about density is that it's intrinsic and it's a fundamental property, which means it differs from one substance to another substance. And so you can use density, and you will be using density, to determine the unknown identity of a substance. So density, as I said, it's mass divided by volume. Units are typically expressed in grams per mil or grams per centimeter cubed. And whatever that value is in grams per mil is going to be the same in terms of grams per centimeter cubed, because 1 milliliter is the same as 1 centimeter cubed. So you should feel comfortable seeing these units and realizing that they are units associated with density. You should also know the formula for density, which is shown here with the star. I know many people like using this little triangle graphic to kind of remember the formula for density and to use it to manipulate the density equation to solve for each of the variables, either volume or mass. So that's what's done here by cross-multiplying and dividing. You'll have practice with density, as I said, in lab, and there are 2 questions on the Canvas worksheet, but you should know this formula and feel comfortable being able to solve it for each variable. So, for example, if I have 250 mils of a liquid and it has a particular mass and I want to know what the density is, I know that density is mass divided by volume. I gave you the mass, it's 322 grams. Volume, I didn't explicitly say volume is, but I see I have a measurement in milliliters, and hey, milliliters, that's a measure of volume, liters. So my density, mass divided by volume, my final units will be grams per mil, and using the correct number of sig figs, my mass has 3 sig figs, my volume only has 2 significant figures. Remember that 0 is not significant because there's no decimal point. So when doing the division of these 2 and using the sig fig rules for division, my final answer should only have 2 significant figures. So my final answer, number and unit, is 1.3.